Well, hey, welcome back there, sports fans. Today we're going to talk about momentum and do a little review over conservation of momentum and some work down here with impulse. So, on our first problem here, it says calculate the momentum of a 1,200 kilogram car with a velocity of 25 meters per second. Well, to find that momentum, we're going to take the mass is equal, or the momentum is equal to the mass, which is 1,200, and take it times the velocity of 25. And what that momentum ends up being is 30,000 kilogram meters per second. All right, so there's hopefully a little bit of review there over momentum where we took the mass, the 1,200, times the velocity of 25. Now let's look at an impulse problem. All right, I've given us the equation force times time equals PF minus PI. And remember that, all right, I'm going to go ahead and include this here, that PF is equal to the mass times the velocity final. All right, what would be the velocity final? So that VF there is velocity final. And then the same thing, of course, would work for PI. The initial momentum is equal to the mass times the initial velocity. So that's how we're going to find PF and PI. So in this problem, it says a 12 kilogram bat is traveling 1,200 or 200 meters per second when it strikes a baseball. If the bat comes to a stop in 0.3 seconds, how much force was applied to the ball? Well, F is what we want to find. The time in this case is 0.3 seconds. So I'm going to go ahead and put that in for the T. Now I'm going to put equals, and I've got to find out what PF was. So I'm going to bring this over here a little bit farther here. And PF is equal to the mass, which is 12, times the velocity final. Well, it comes to a stop, so it's going to be times 0. So that right there tells me that PF, or 12 times 0, PF has to be equal to 0. Now let's find PI. PI is equal to the mass, again, which was 12, times the initial velocity, which was 200. This bat was really moving. So that initial momentum is 24,000 kilogram meters per second. So now I'm going to come back over here and put this information in. Well, what did we find PF to be? We just found PF was 0. So over here, I'm going to put 0 minus PI. Well, what did we get PI to be? We said PI was 24,000. So now it's just a matter of finding that force. The force then, if I divide both sides by 0.3, this force then is going to be 80,000 newtons. All right, 12 kilogram bat, 80,000 newtons along the way. Now, what that leaves for you guys then is up here, you've got 1, 2, 3, 4. You've got 5 momentum problems. You can easily get that done in about 3 or 4 minutes. And then you've got 2 slightly harder problems here dealing with impulse that follow the exact same way that we did this up here. Well, hey, I hope that was helpful and beneficial for you guys. I'll catch you on the flip side.